Hello everyone. Today I will continue talking about chapter 1 chemical formula and moles for chemistry level A IG. In this part I will talk about atomic symbols and formula, compounds, relative molecular mass, mass spectrometry, and how to calculate relative atomic mass, and how to calculate the number of moles of a compound and the relative formula mass. As always, I will provide a link for to download the material, and also I'll provide a link for the website where you can find download the material, and also you can find the link for all videos related to the subject. Atomic symbols and formula. All elements are arranged in periodic table with a unique symbol for each one of them. Usually it is formed of one letter or two letters. If it is formed of one letter, it is written in a capital letter and indicate the name of the element, which is something like hydrogen. And here we have the atomic number, and down is the atomic mass. If it is formed of two letters, we have the first one is written in capital letters, and the second one is written in a lowercase, something like iron. If it is written in both of them in capital letters, it means it is a compound, not an element. Let's take an example. I have something like CO, with both of them are written in capital letters, and CO, one of them is written in a capital letter, the other one is written in as a lowercase. The second one is actually the element cobalt, but the first one means is I have a carbon atom and oxygen atom. This is a carbon monoxide, and this carbon monoxide is a compound, not an element. Another example, if we looked at something like H2O, now we have both of them are written in a capital letters, but I have this small number that is written down one of them. So this is actually water, and in here we could see that it means I have two hydrogen atoms and I have here one oxygen atom. Another example, if I have something like H3BO4, all of those are written in capital letters, and the numbers here indicates that I have 3 hydrogens atom, and I have here 1 phosphorus atom, and I have here 4 oxygen atoms. Let's take an example. How many atoms of each element are present in one formula unit of each of the following compounds? First one, AlOH by 3. We could see here that the L is written in smaller lowercase, but the A and OH is written in capital letters. So this means that I have here this one, the formula of aluminium, and I have only one atom of aluminium. Plus I have here between two brackets what is written as OH. OH is actually hydroxyl group, and I have 3 hydroxyl groups. And the hydroxyl group itself is formed of 1 oxygen and 1 hydrogen. So for this one, if I looked here, I could see that I have 3 oxygens and I have 3 hydrogens. So the number of atoms in this compound: 1 aluminium atom, 3 oxygen, and 3 hydrogens. Let's look at the second example, NH4 by 2 SO4. The first one is indicated in capital letters, and it is actually a group that is called ammonium group. And this ammonium group, I have 2 ammonium group. Each ammonium group contains 1 nitrogen and 4 hydrogen. Because I have 2 of them, so I have in each group of ammonium group 1 nitrogen and 4 hydrogens. Also I have here SO4, 1 sulfur, and I have 4 oxygens. So if I look here, I have 2 nitrogen atoms. I have also I have to multiply the 2 by 4, so I have 8 hydrogens. And I have 1 sulfur. And I have 4 oxygen. So I have 4 oxygen atoms. This is how I can write the atoms of a certain compound. Now, compound is relative molecular mass. If I wanted to know what is a molecular mass of a compound, I have to know, I have to sum the relative atomic masses of the atoms in this compound. Let's take an example. If I wanted to know the relative molecular mass of something like ethanol C2H6O, my relative molecular mass will be the relative atomic mass of 2 carbons plus 6 hydrogens plus 1 oxygen. If I wanted to convert this into numbers, my relative atomic mass of carbon is actually 12, and my relative atomic mass of I have 6 hydrogens multiplied by relative atomic mass of the hydrogen, which is 1, and I have 1 oxygen multiplied by relative atomic mass of the oxygen. The sum of that is equal to 46. So my 46 actually is the dimensionless unit. The relative atomic molecular mass is the dimensionless unit because it is actually the sum of relative atomic masses, which is also a dimensionless unit. The mass spectrometry. The mass spectrometer is used to measure the mass and the percentage of each isotope of an element. In this mass spectrometer, we vaporize a sample and we let it travel through a tube that is actually bended, and each atom of the same element travels at the same speed. But if I have a heavier atom, it will just reach the detector, my detector, so I receive those atoms at a detector that can read the number of atoms and the mass of atoms according to their speed. So the first one which reaches the detector first would be the lighter atoms, but the slower one will be the heavier atoms. Also, I will find because it's a bended shape, so the ones that deviate more will be the lighter ones, but the heavier ones will deviate less than the lighter ones. So how to calculate the relative atomic mass from the mass spectrometer? So I have here the mass spectrum of neon. I could see that I have here a peak around 20 that says 90.9, and another peak around 21 which says 0.3%, and at 22 which says 8.8%. So the mass spectrum of neon would be the sum of all those multiplied by their percentage divided by 100. So let's take the first one, which is the mass is around, mass ratio is 20. I will multiply it by the percentage, which is 90.9. I will sum that to the other peak, which is 21, by its percentage, which is 0.3, plus the third one, which is 22, multiplied by its percentage, which is 8.8. I will divide all of those by 100 because what I see here is actually a percentage. So it is multiplied by 100. Those are multiplied by 100. This is why I have to divide by 100. That would give me 20.2. So my atomic mass can be my relative atomic mass can be deduced from this mass spectrum, which is 20.2 for neon. Now moving to another example. From the germanium mass spectrum, we find out that this spectrum shows 1, 2, 3, 4, 5 peaks. Each one of them have a certain percentage, like we did before. So the relative write the isotope formula for the heaviest isotope of the germanium. So I need the relative isotope formula for the heaviest only. So if I looked at the heaviest, that would be this one, which is 76. So the 71. So the formula for that would be germanium 76. And if I wanted to know the percentage abundance of each, use the percentage abundance of each of them to calculate the relative atomic mass of the germanium in general. So in that case, I will write the relative atomic mass of germanium would be equal to the percent of each one of them. So if I started from the lowest, which is the 70, multiplied by its percentage, which is 20.6, plus the second one, which is 27.4, which appeared around 72. So I have the second one at 72, and the percentage is 27.4. The third one plus the third one, which appeared around 73, with a mass 73, plus 7.7, plus third the last one is the first one is 74 multiplied by 36.7, and my last one is actually plus the last one, which appeared around 76, multiplied by a percentage, which is 7.6. All of that will be divided by 100. I will have the relative atomic mass of germanium, which is 72.7. The number of moles of a compound. Now, if I know the molecular mass of molecular mass of a compound, I can, and I know how many grams did I have of this compound, I can calculate the number of moles of a compound. Let's take an example. How many moles are there in 60 grams of glucose? And this is the formula for the glucose. So first I need to calculate the relative molecular mass for the glucose. So my relative molecular mass of glucose would be equal to I have 6 carbons with relative atomic mass, which is equal to 12, and I have 12 hydrogens with relative atomic mass of 1, and my oxygen, I have 6 oxygens by relative atomic mass, which is 16. This would be equal to 180. So now I know the relative molecular mass of for this compound. What I need to know is how many moles. So if I applied this relation, which says the moles of moles of glucose would be equal to the grams of compound that I have, which is 60 grams, divided by the relative molecular mass, which is 180. That would be equal to 0.36 moles. I can calculate it in an easier way, and in that one, it will help me if I understand this step. It will help me further when I do more complicated examples. I have to know that for each 1 mole of glucose, there is 180 grams in each one of them. So if I took the 60 grams, which I have, which is given, and I multiplied by a conversion factor, which says each 1 mole is equal 180, grams, this would give me the ratio 0.36 moles. How many moles of the substance are there in each 100 grams of sodium dichromate? First, I need to find out the relative molecular mass of the sodium dichromate, and from that I can convert grams of sodium dichromate into moles by using the conversion factor. So first, let's calculate the relative atomic molecular mass of sodium dichromate, which would be equal to, I have 2 sodium, I have 2 chromium atoms, and I have 7 oxygens. So from that I can multiply the 2 by the 23, which is the relative atomic mass of the sodium, plus 2 multiplied by the relative atomic mass of chromium, which is equal to 52, plus 7 multiplied by the relative atomic mass of the oxygen, which is equal to 16. This would give me 262. This means each 1 mole of sodium dichromate contains 262 grams of sodium dichromate. So if I looked here and I said, okay, my the number of moles would be equal to the given unit, which is 100 grams, multiplied by the conversion factor, which is 1 mole of sodium dichromate, divided by the 262 for each grams for each 1 mole of them. That would be equal to 0.38 moles. So I have 0.38 moles in each 100 grams of sodium dichromate. So I have here what is called relative formula mass. So my relative formula mass is actually the relative formula mass is the mass for a compound that can form ions. Something like MgOH is actually when magnesium hydroxide, when it dissociates into water, it forms magnesium ions and hydroxyl ions. So for that, if I wanted to calculate the relative formula mass, it will be exactly like calculating the relative molecular mass. So if I wanted here to calculate the relative formula mass for this magnesium hydroxide, it would be equal to, I have 1 atom of magnesium, so I will multiply this 1 by the relative atomic mass of magnesium, which is 24.3, plus I have this between 2 brackets I have 2, so I have to multiply the 2 for each atom. So I have 2 multiplied by the relative atomic mass of oxygen, and I have 2 multiplied by relative atomic mass of hydrogen. This means that the sum of this would be equal to 58.3. So my relative formula mass is 58.3 for this compound, which is magnesium hydroxide. Another example, calculate the relative formula mass of magnesium nitrate, and I have here 6 water molecules. It's similar to the previous example. I only have to multiply my relative formula by the atomic mass of water. So I here so if I want to know the relative formula mass for this compound would be equal to, I have 1 magnesium atom, so I multiplied 1 by the magnesium atom relative atomic mass is 24.3, and I have here 2 nitrogen atoms, 2 multiplied by 14, and I have 2 by 3, which is equal 6 oxygens by relative atomic mass 16, plus I have 6 H2O. For 6 H2O, this means I have to multiply the 6 by the 2 and the 6 by the O. So I have 12 hydrogens and I have 6 oxygens. So here would be plus 12 multiplied by relative atomic mass of hydrogen, which is equal 1, and 16 multiplied by 6 atoms, 6 oxygen atoms, and the sum for that would be equal to 156.3. So my relative formula mass is 256.3. Now if I wanted to know the reacting masses, so we do have what is called stoichiometry of equation. This stoichiometry of equation let us know the ratio of reacting and the reacting compounds and the product. This stoichiometry tell us how many moles are involved in the chemical reaction. If I looked at this example, it says here that I have 1 iron oxide ratio against 3 moles of carbon monoxide. I said here carbon monoxide because the C is capital and the O is capital. And I have here my product is actually 2 iron moles, 2 moles of iron, and I have 3 moles of carbon dioxide. So from that ratio, I can know first I knew the number of moles. So my number of moles would be the mass over the molar mass, total molar mass of the substance. And the mass of the substance in gram would be equal the opposite. So now I have the moles, and I will multiply this moles by my molar mass. Let's take an example. It will just make it more easier to understand. Example: magnesium burns in oxygen to give magnesium oxide. Magnesium, and this is the equation. First, I need to balance this chemical equation. If I looked here, magnesium plus oxygen to give me magnesium oxide, I have here 1 atom of magnesium and have here 1 atom of magnesium, but in here I have 2 atoms of oxygen and I have here only 1 atom of oxygen. To be able to solve that, I have to multiply my product by 2. But if I multiplied my product by 2, this means I have to multiply also this part by 2 to be able to have here 2 magnesium atoms and here 2 magnesium atoms. So if I multiplied this part, I will leave oxygen as it is, and I multiplied this part by 2. So now let's count the number of atoms. I have 2 magnesium atoms and 2 oxygen atoms. I have here on that side 2 magnesium atoms and I have 2 oxygen atoms. So to be able to know how much magnesium is used, I have to multiply the number of moles by the relative atomic mass of magnesium. So the number of moles, which is 2, multiplied by the relative atomic mass of magnesium, which is equal 24.3, that would give me 48.6. This means I have 48.6 grams of magnesium that is reacted to give me this magnesium oxide. Let's take an example. Calculate the mass of sodium peroxide formed when 4.8 grams of sodium is burned in excess of oxygen. First, I need to balance my chemical equation. So I have to check my equation if it is balanced or not. Na2O2. I could see here I have 2 oxygen atoms, 2 sodium atoms, but here I have only 1. So I have to multiply this by 2. So I have 2 sodium atoms on that side with 2 oxygen, and I have here 2 sodium atoms with 2 oxygen. Now now I balanced my chemical equation. My next step is converting my grams of sodium into moles of sodium. And from moles of sodium, I will use a conversion factor between the moles of sodium and the moles. I will know the moles of sodium peroxide, and from moles of sodium peroxide, I will calculate the grams of sodium peroxide. Let's do this one in just one single step. So I will use my provided or given unit to be able to obtain my desired unit. First, so my grams of sodium peroxide would be equal to. Like I said here, I have to use grams of sodium, that is given 4.8 grams of sodium multiplied by moles of sodium. So now multiplied by conversion factor to be able to convert the grams of sodium into moles of sodium. This means I have to know that each mole of sodium contains 23 grams of sodium. Another step would be using the ratio between the moles of sodium against the moles of sodium peroxide. I could see here that each 2 moles of sodium is consumed to produce 1 mole of sodium peroxide. So I have 1 mole of sodium peroxide and against 2 moles of sodium. And my last step is using conversion factor to obtain the grams of sodium peroxide. So from first I have to know that the molar mass of sodium peroxide is actually equal to multiplied by 23 plus 2 multiplied by 16. This would give me 78.0. So this means each 1 mole of sodium peroxide contains 78 grams of sodium peroxide. So from here I could say that 78.0 grams of sodium peroxide is equivalent to 1 mole of sodium peroxide. From that I could see that is equal to 8.139, which is around, if I approximated, 8.14 grams. So for each 4.8 grams of sodium I have 8.14 grams of sodium peroxide that is produced. Now I have done this one in a single step. I want to make sure that I haven't made any conversion, if I used any wrong conversion factor or not. So if I cancelled my units, I should end up by grams. So if I looked here, if I cancel these grams, this unit with this unit, and the moles of sodium against the unit of moles of here, and the mole unit here against this unit here, I end up by one only single unit, which is the grams. So this is how I can verify that my answer is correct, by looking at the last unit that I obtained and I cancel the units in my steps. I will continue talking about this chapter my next video. Please hit subscribe to the channel where you can watch more videos. Thank you and goodbye.